Hello, everyone, and welcome to today's SANS APAC webcast. Java on the server, what could possibly go wrong? My name is Carol Auth of the SANS Institute, and I will be moderating today's webcast. Today's featured speaker is Adrien de Beaupre, SANS Certified Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Adrien.
Hello, everyone. My name is Adrien de Beaupre, and I'm here in Canada, but I will be in Australia within a few weeks to introduce our course, Security 642. The purpose of this course is to talk about the more advanced web application pen test and attack techniques that we're seeing today. How we differentiate our course from the more basic 542 courses, we are where that course stops, and then we move forward. So one of the topics I've extracted from the course is a topic that I've covered, and it's called Java. Putting it on the server, what could possibly go wrong? And then we'll address struts and Jenkins. These are both very popular and interesting applications that we've seen over the past 18 to 24 months have both had some very significant issues. So first off, Security 642 is hopefully, we believe, the most advanced web application penetration testing course on the planet, possibly the galaxy. Both the depth and the length and the breadth of topics that we cover, myself and my co-author Justin Searle have written this course specifically to be for attacking and assessing more modern web applications. So I'll be in Melbourne in May of this year, and I'll be delivering this course, Security 642. It's designed to show you the more advanced skills and techniques that are required to assess how applications work today. It's not the more basic course, which is called 542, which covers the more essential skills of how to do pen testing, but stops before you get into things like REST APIs, or cryptography, or frameworks and why they matter, and the more advanced attacks that we see in more modern environments, in more modern applications. So one other thing I'd like to bring up is, okay, so in many environments, you've done a pen test or an assessment, and you've already mitigated some of the lower hanging fruit. You've already made some changes to harden the application to make it more resistant to attack, which means the next time you do an assessment, the techniques you used the first time don't work anymore. This is again where 642 comes in. It's addressing how do you do bypasses, how do you attack firewalls, how do you do filtering, how do you do the things that we need to do to really address risk in modern applications inside environments where, the basic techniques don't work anymore. So one of the primary topics of this course addressed on the day 2 portion of the content is frameworks. Frameworks help the developers develop more quickly. They do not have to write code, for example, for authentication. They don't have to write code for authorization. There's likely some security built into the framework, which is good unless of course they turn it off. So if we can identify an application uses a particular framework, examples might be Cold Fusion or Struts or ASP.NET or PHP. There are many frameworks out there. Once we identify a framework, that allows us as a pen tester to first identify there might be known vulnerabilities in that framework. There were 4 separate vulnerabilities giving us remote code execution in Struts in 2017. Today, there was a vulnerability released in Drupal, remote code execution. Last year in WordPress, there was a REST API attack that gave the attacker the ability to modify or deface any content in that framework. Other things we can see are classes of issues, for example, mass assignment or type juggling. Now, that's not the topic for today, but again, they're covered in our course in day 2. They are issues or classes of issues that affect all frameworks, no matter which one you use. We can test a framework for default settings and patterns. For example, a number of developers may use a framework and may have common patterns on how they solve problems, which may allow us to identify weaknesses in those patterns. Now, the key aspect of a framework is any library or framework that may have an issue, a vulnerability within it, every application inherits that vulnerability. So if, for example, struts, if itself has a vulnerability and you develop your application in struts, you inherit that vulnerability. So struts 2 was a marked change from struts v1 in that it was not a .do, it was a .action resource extension. And this form allowed you to call the model an MVC, a model view controller, that allowed you to abstract the application and not have to concentrate on specifics in the code. You could just call an action, and it was much easier for the developers to create an application without having to dive deeply in the code. One of the aspects of struts 2 is something called OGNL. This object graph notation language is a method for passing parameters to the application. Traditionally, in CGI format, you sent parameters either in the URL, in the get, with the question mark, name equals value, ampersand, name equals value, name equals value. For example, login.php, question mark, username equals Adrien, and password equals password would be passed into the application in CGI format. Another format would be in a post as a payload, same format. A third way to pass parameters into an application are using JSON, JSON, JavaScript object notation. A fourth way might be XML over SOAP. So OGNL is very specific to struts. So if there were an issue with OGNL, all struts applications would also have that issue. So you never guess. In 2013, there were a number of OGNL issues. So many struts 2 vulnerabilities in CVEs, or common vulnerabilities and exposures, come from OGNL. In fact, one of the issues last year in 2017 was issued to this parameter passing code. The issue may be in the code server side that receives the OGNL message, parses it or tries to understand it, separates it into its components, and then does something with it. The code that processes that parsed code may have issues and be vulnerable. In fact, one of the vulnerabilities might be ungraceful or error handling that does not handle abnormal inputs correctly. So in 2013, there's an issue, CVE 2013-2135. At that time, the Apple developer site from Apple Corp may or may not have had an issue. They never publicly confirmed it, but they kind of went away for a little while. So let's talk about Equifax. This is a big deal in the United States and actually the UK and Canada. I do not believe they deal in APAC, but imagine 140 something million records go missing. Oops, or was it 140? No, it was a large amount. In any case, 140,000? Anyway. So they received an advisory saying there's an issue with struts. They received the email, they passed it around to all their people, they scanned for struts, and here's what's weird. They never found it. But later on, they observed some traffic that was a little strange, and they didn't do anything. Then they observed some more strange traffic, and they took their application offline. Here's what's interesting. This application was using struts, but when they scanned it, they couldn't find it. What's also weird is they didn't know they were using struts in this application. You would imagine that they would have some sort of dependency list, some sort of build documentation, some sort of architectural documentation that would tell them, by the way, you have struts. So Equifax is the sarcastic way we refer to Equifax. So this is the CVE that came out. Apache struts basically runs commands via a specific crafted content type, content description, or content length header. And it contains a CMD equals something string. Its CVSS v3 base score is a perfect 10. That's the highest you can get. So you'd imagine a 10, a critical, you would really look for this thing. And the fact that anyone, not even logged in, did not have to authenticate, did not have to have any authorization, could run any command on your server. And what's even weirder is the struts CVE code that came out, the proof of concept, the code that came out called struts-pwn, actually echoed back the response of the command. It was not blind. It was actually full in-band command injection, arbitrary RCE against the server. So takeaway from this slide, super bad, right? Once you explain this to management, this is super bad. We really need to fix this. You would think they would go looking for it. So this is taken from the, there was a big to-do in the United States. Although I live in Canada, we can't pay attention to what goes on down there. And they scanned their servers. They did not find struts. They did not find any struts. So for months afterwards, they were still vulnerable. Now, later on, they blamed some person. Some person worked somewhere in IT that did not patch. But honestly, would you know if you had struts installed or any other framework or any other library that your application depended upon? So it's really easy to be a backseat driver, right? An armchair quarterback that looks at them and says, oh, for shame, you did all these things wrong. You are an organization that holds financial data and personally identifiable information from millions of people in 3 different countries, although they also actually operate in South America, Central America, and the Caribbean, but that part of the database was not breached. So you hold all this data. You'd imagine your threat model would tell you that people might want to attack you, right? You'd imagine that doing vulnerability scanning, you'd find these issues. You'd imagine that you'd categorize each asset and classify data saying, you know, this is probably kind of important stuff that we should encrypt, which they did not do. You'd also imagine they would monitor their environment. Imagine several terabytes of data leaving your network because you've been compromised and they didn't notice. And then just doing threat hunting. Again, a very popular term, which I imagine just means looking at your stuff, which is what we called it back in the 90s. But all these things you'd imagine they should have done, but they didn't. So again, it's very easy for us to criticize them for the things they did or did not do. But what if it was actually kind of hard to find? But it wasn't just the one. There were 1, 2, 3, 4, 5 different vulnerabilities in struts, one of which is in struts v1 in 2017 between March and September. In fact, I was paying attention on one day and I noticed the 52 attack came out. The very same day, 53 came out the very same day. So it's like, holy cow, 2 remote code execution attacks against struts came out in the same day in September. So wouldn't the other ones cause you also to go back and take a look like, are we sure we don't have struts? Are we absolutely positive that we do not have any of these problems, any of these issues? So here's the weird thing. If you're not fairly familiar with your application and you ran some of the code that was out there and checked, it would say you are not affected. And you're like, but what? So I have an application and I called it Struts. It actually is called Showcase. I downloaded it from Apache last year and it's vulnerable to all these things. And I installed it on a server and I ran the code against the server and it said not affected. And I was curious, why did I have a false negative when I ran that code? And I can show you that. I'll do a demo. I'll demonstrate this actually against the server that I have in my lab, and you'll see the same thing. So if I can't find it running the code, how do we find it? So the thing is, you have to hit a dot action. Oh, if you don't hit a dot action, you're not invoking the code server side that contains the vulnerability. So I need the actual URL and feed it to the tool. If I didn't know that, I would completely miss this vulnerability. So Showcase is literally the application that the Apache Struts Foundation have created to show off all the features of their application. If you downloaded the one that was available in early March of 2017, it was in fact vulnerable to all 4 of the Struts 2 vulnerabilities of that year, and presumably the ones that are probably coming up this year in 2018. So I can take the actual URL that indicates the .action and feed it to these 2 files, struts.po, and I showed you previous slide, or nmap, which I'll demonstrate fairly shortly, and it should identify the issue because it is vulnerable. So that's pretty interesting. So here's an example in the slide. I run nmap the first time, it doesn't find it. If I run nmap a second time with the correct argument and the full path to the actual .action, it says you're vulnerable. That's interesting. So here's struts poem with the correct URL. So let's demo that. Like, you know, Adrien, enough words. I have to actually see. So this may take a sec because I'm in Canada and you are not, or you may be somewhere else. And hopefully at this point, you should see a big black terminal screen on a Samurai WTF. So first off, I'm going to take those first commands I showed you on that slide. If I run the nmap script against struts with no arguments, what happens? So nmap -- script, the CV I just discussed, on the port it is struts, and hit enter. And it should say something right in there saying you're vulnerable, but it does not. So what happens if I hit port 8080 on that server with a browser? It says, oh, I'm Tomcat. I'm not hitting the actual application. I'm hitting the web server. So what if I put in the name Showcase and hit enter? Notice that it redirects to the showcase.action. So I wonder if I don't do that, what if I feed port 8080 with Showcase without the .action file? This is what's interesting, is nmap, does not follow the redirect. It says, I see nothing. So I have to hit a .action file. So if I put in /showcase in a web browser, it says showcase.action. It expands and redirects it to that. If I feed that to the nmap NSE, it goes, oh, now I get it. You are vulnerable. Even further, if I use the application and click on File, Upload, Single File Upload, so now I'm hitting Showcase, File Upload, Upload.action. So let's feed that URL into the nmap script, where I'm actually invoking functionality that we know should be vulnerable. So I copy and paste that, and it says vulnerable. So notice I scanned twice and it said not vulnerable. I was more specific in the URL, hitting a .action. It says you are vulnerable. All right, show me struts pwn. Struts pwn -h, it says I want a URL, and you can do a -- check. Okay, well, let's do a URL that does not contain .action. Let's do a URL that only contains /showcase and see what happens with struts pwn. And it says, oh, look, you know what, dude? I ran this command and it worked. -- check, and mate, we are vulnerable. So this Python script knows if it hits /showcase and gets redirected to the action file, attack it. So I could actually change that command, couldn't I not? And go -c, what's your name? And it says, I'm Linux, This is my kernel version, which means I'm also probably vulnerable to dirty cow. That's some pretty darn useful information. And this is what's interesting about this attack, is it actually echoes back the response from the command. This is not true of all attacks of this nature. In fact, many modern attacks are completely blind. You do not see the response. So struts, pretty easy to run, right? Like this would not be hard to figure out. I figure your average 12-year-old could probably figure that out. Download this file and run it, and it would work. What does that tell you about Equifax then? About their capabilities and their security monitoring? So my sarcastic comment here is, I'm known as the sarcastic Canadian. Usually I ask for a virgin goat to be sacrificed to the demo gods to make sure my demo works. My demo worked, so no goat sacrifice was required. So 2017 was a very bad year for struts. 3 or 4, or if you include struts 1, 5 RCEs. That's not good. And of course, struts is based on Tomcat. It's Java-based, and it inherits vulnerabilities also from Java libraries, which also can be an issue. Wow. Let's look at another one. This one's a little older. This one's from 2017, 5638, Jenkins. If you're not familiar with Jenkins, Jenkins is kind of like a groovy shell. It's something you use to automate code compiling and regression testing. It's used in development environments. So it often has access to a lot of really critical, important aspects of an enterprise where you do your own development. It's got execute arbitrary code via something special, a serialized object. And it's got this commons collections library that's the real problem. So back up a step. It's not just Jenkins. It's the library in Java it uses that is vulnerable, which means other things are also vulnerable, like, for example, WebLogic, WebSphere, JBoss, OpenNMS, and quite a few others. A very, very common library. Oddly enough, it got a 7.5 for CVSS v2. Reason being, it's completely blind. You don't see the response. And it's a little bit more difficult to pull off because you're actually filtering through a Java system call, which may blacklist certain functions and certain syntax in the command you inject. So serialized killer is a script you're supposed to run against Jenkins. What it does is it connects to the Jenkins port, often 8080, It queries that port, asking it, where is the CLI or command line interface port? It then takes a special payload that you have to create and sends it to that port. So serialized killer will say yay or nay whether or not you are vulnerable. So if you run it against Jenkins, it should say yes, you're vulnerable or not. So to create the payload, you actually use a special YSO serial jar, and you have to give it the name of the collection and a command you want to run to create a payload. So if you create a payload and then run the Linux file command, it tells you, hey, by the way, I am a serialized object for Java. So let's briefly talk about what a serialized object is. Serialized object is also similar to JSON, BSON or binary JSON or XML or other formats used to pass data back and forth between the browser or client and the server. Now the server may give you a serialized object, like a cookie, and later ask for it back. It may assume that you haven't changed anything. So if it deserializes that object, assuming you haven't changed it, and then does something with it, you may have your abnormal input affect the application server side or do something bad in the case of Jenkins. So literally, Jenkins will accept a serialized object from the command line interface and run whatever is in it, assuming that you could not have changed it. That's not a good assumption, is it? So we could have injected, in this case, an attack. So that creates the payload with YSO serial. There is actually a jenkins.py file, a Python script that will take the payload, connect to Jenkins on port 8080, query for the CLI port, find the CLI port, send the serialized object, and the payload will then run on the server. Yes, so Carol's also mentioned if you have any questions, please feel free at any point in time about either the struts attack, the Jenkins attack, or web applications in general, or 642, the course that I've written with Justin, or 460, the course I mentioned, and we'll bring up again at the end, of course, when I put on my marketing hat. So here's the thing about Jenkins, completely blind, I can't tell if the attack worked. So if I had access to the server, I could also check to see if the attack worked. Okay, so let's do demo time. So let's go back to Samurai. So your screen should, in about a second or so, flip back to the black screen. First off, I'm going to go look at Jenkins. So I have jenkins.sec642.org. And it says, oh, by the way, buddy, try 8080. Mate, you're on the wrong port. So hit 8080, and it says, welcome to Jenkins. Oh, but it's been secured. If I don't have username and password, I cannot run jobs, right? So you create jobs in Jenkins, and it goes and executes them either local, or if it has credentials against remote systems. So this is one of the critical aspects of Jenkins, is it often has access to all kinds of other things. Way down here, you should see the version. See this Jenkins VER 1637 way down the bottom right. I highlighted it there. This is the vulnerable version of Jenkins. So in both cases for struts and Jenkins, I went to the appropriate websites, downloaded the vulnerable version of the software, installed it, and have it in our lab environment to perform exercises in the 642 course range. That's not always the case. In some cases, we've actually discovered or identified a vulnerability we want to talk about and literally wrote a vulnerable application because either there was only a commercial product or we didn't want to make use of the open source product because that would be, perhaps picking on them. Although you could argue I pick on Jenkins a bit here. So they're vulnerable, but it's secured. I have to log in. It's not completely secured. It's not over HTTPS, but it doesn't really matter in this case because it's actually not port 8080 I'm going to talk to. It's the CLI port. So how do I find the CLI port? I talk to Jenkins at the appropriate site, port 8080, and I just do curl, and curl tells me, see this right here? The CLI port is on 36263. So what the Jenkins script will do is talk to the Jenkins server on 8080, grep down and identify the CLI port, take the payload we create, send it to that port, and then stop. Because we get no feedback from the port to see if the command worked or not. So to do that, I'm going to actually SSH into the server. Watch, I'm going to type in my password. Nope, there we go. All right, so let's take a look in /temp. We have 4 files in /temp. All right, so hold on to that thought. So if I go back to the system I'm on here in Samurai WTF, I have a couple of things. One, I have the NSC script I ran against struts. I have the serialized killer I could run against Jenkins. I have the struts-po and I ran against struts. I have jenkins.py and I have YSO serial. So Jenkins is the Python script to deliver the payload to the Jenkins server. But serialized killer is when it's supposed to tell me if the system is vulnerable. I use -h and it says --URL. Alrighty, so serialized killer --URL. And I'm going to have to make sure to specify the port 8080. Oh, here's interesting. I had to look at the script and realize that they actually don't want you to put the port in. They just want the URL, and they go and check a number of ports Jenkins might be on. So it says you are vulnerable on port 8080. Notice if I read what they told me, which says put in URL, and I put in URL, it didn't work. That would be a false negative. Isn't that interesting? I've often get asked, Adrien, what's the worst thing about working in vulnerability assessment and pen testing? And people go, it must be false positive, right? I'm like, no. False positive is a problem that can be solved with data, tools, and an analyst of sufficient skill and experience. False negative is the true problem with our industry, where if I ran this line, because it asked me for a URL, it said not vulnerable or said nothing. Whereas if I read through the code and we can look at the code, it's actually expecting just a host name, not a URL. And it goes through and checks various ports. For example, 8080, looking for a vulnerable response. So you have to be fairly knowledgeable in your tools. Pay a lot of attention to the details. For example, in this case, serialkiller.py, which I've changed, is actually running through a proxy, and we'll show that in a sec, called Beaupre. It actually says, give you a URL or a file, and then it goes through and checks port 80 and port 8080. So it doesn't want a URL. It only wants a host name. Now notice it looks for other things like JBoss, Jenkins, WebLogic, WebSphere. Isn't that interesting? And it creates and crafts the URL from the host name and these ports, and then goes looking for those applications on those ports. So if you didn't check that and didn't know that, you'd have a massive false negative right there. All right, so let's actually do this. I have to java-jar why-so-serial. And it tells me these are the different things I can do. Now, if I do some research on Jenkins, Jenkins research tells me it's Commons Collections 1 that's vulnerable. And if you remember back when I looked at the advisory told me it was Common Collections. Didn't tell me 1, 2, 3, or 4, but we'd try them each, right? We'd try them all, in which case it actually is Commons Collections 1 through trial and error. So I put in that space command execute. So let's just create a file /tmp/Adrien and put that into my payload. So now I have a file called payload right there. I wonder what it is. I use the file command against payload. It tells me this is Java serialization objects version 5, so it's properly formatted. I wonder if I can see what's in there. So use a XXD as a hex editor to take a look at what's in the file. And if you scroll up all the way to the top, you see a whole bunch of stuff going on. And it looks like some Java stuff, and I'm not sure what's going on there, but oh, right there. That looks familiar. So in this object is basically saying execute the command that Adrien put in there. All right, let's look at Jenkins for a sec. Jenkins.py-h. Whoops, it doesn't want -h. It doesn't have a help file. What a drag. People who don't have, oh, there it says Jenkins.py, host, port, path to payload. This one is not looking for a URL. Host, port, path to payload. Then basically, I've also proxied it, but it's not using HTTP. It actually uses a different protocol. The protocol it uses is the CLI port protocol for Jenkins from the port it found on port 8080. So let's repeat that. So /Jenkins.py, the name of the system, the port, and the payload. Oh, this didn't work. I've run this enough times that if it hangs there, it's not working. This is actually the string that looks for if it's vulnerable. So I'm going to have to remake my payload. And let's see if I type something wrong there. Java-jar, why so serial, comment selection 1, touch temp Adrien into payload 2. And I've run this enough times to know that that can be a problem if it hangs right there. No way. Twice in a row. Come on. I've never had fail 3 times in a row. Interesting. This is super embarrassing. Wow. Just for fun, I'm going to take out this. So Java, I do it from scratch, -jar, why so serial of commons collections 1 of quote douch/tmp/hello redirect into payload. Hmm. 8080 and payload. Ah. Wow. 4th time is this charm. That is so interesting. Wow. This is what happens when you fail to sacrifice the appropriate virgin goat. It fails 3 times in a row, and then the 4th time it works. Oh, wow. Well, never let it be said that Adrien's not willing to take a risk and run live devo in a webcast where people will see it around the world and for months to come, because this is going to be recorded and you can come back and see it at any time in the future. So, 4th time's a charm. If it doesn't hang to sending payload, it actually works every time. And as I mentioned, this is the string we look for that indicates this is a vulnerable service on that port. Wow. Okay, enough demo. Hopefully you have some questions for me, because, you know, this is getting towards the end of the webcast. Again, this is a webcast specifically for the APAC region because I will be delivering the course 642 Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques in Australia, in Melbourne. I've not been to Australia for at least a year now, possibly 2. And we're also going to be delivering, oh, there's a lovely picture of my co-author, Tim Medine. He is my co-author with the SEX 460 course, Enterprise Threat and Vulnerability Assessment. Our logo is that funky little logo in the middle there. And the flip side of our coin is the HMS Enterprise, because it's the Enterprise course. So in Sydney in August 2018, Tim will be presenting for the very first time in APAC, actually only for the 4th time ever on this planet, our course 460 on how to perform threat assessments and vulnerability assessments against enterprise class organizations. This is our contact information for Justin and myself. We are the co-authors of this course, the Advanced Web Appendix course. I believe it's probably time for question and answer. And I'm actually going a little bit short, although, let's see if there are any questions.
Hey, Adrien, it's me.
Hey.
Hey, we don't currently have any questions, but if someone would like to ask one, we will absolutely answer it. I do have a question myself.
Mm-hmm.
When you're, the person who is supposed to be responsible for struts and some of the things that you've covered today, how are you able to translate the severity or the risk of these issues to management so that they understand that, hey, this is a thing, we should fix this thing, and if we don't fix this thing, it's going to be a bigger thing?
So the first thing you do is called qualitative analysis. Qualitative analysis is, how bad is this really? Can we come up with a description or a compelling story? Oddly enough, discussing things with management from an information security point of view is like telling a story. And I know, Jason, that you're a storyteller. So telling a story to management that is credible and compels them to agree to change. For example, deploying a patch might be very simplistic mitigation. However, in some cases, addressing an issue is not deploying the patch. It may require architectural, organizational, or even cultural changes across an entity. So basically saying, you know what? We should make a massive change, and we should change everything we do with IT because of this issue. It's that severe. So it's all a compelling story called qualitative. We can also do quantitative analysis. We can come up with numbers. The problem with numbers is they have to come from somewhere. So if I say that severity is a 10, what does that mean? Well, it means we assign a rubric or a series of criteria and values to how bad is it. One of the values is impact. Impact can be very small, for example, a simple workstation attack, or massive in the case of Equifax or other attacks where our crown jewels, the things we value, are going right out the window. So we can assign values, or we can also be qualitative, high, medium, low, critical, with how bad something is. But we throw in other criteria, for example, not just how bad is it, what is the probability of it occurring? Has it occurred to us in the past? Is it occurring to other people like us right now? So there's severity in terms of impact. There's probability of it occurring. There's vulnerability. Yes, are we vulnerable or not, which is the key determination from a technical point of view. But also, how qualified or how sophisticated an attacker would be necessary to pull off that attack. If it requires a nation state to pull off an attack, and that is not part of my threat agent model, I might not be very concerned. But if I am myself a department of a government, and I do in fact have nation states who may be threat actors for me, I may have to be concerned about someone who is highly motivated, has the resources, and has the time and sophistication to pull off the attack. But if the attack is so simple, in the case of both of these, Struts was trivial. I could train a 10-year-old to pull off that attack in probably 5 minutes or less. Whereas the Java deserialization attack, a little bit more complex, and actually, oddly enough, it failed 3 times in a row on me, which is funny. But, you know, I'm experienced enough to troubleshoot that and make it work. So sophistication level on that one might be a little bit higher. But if I had to write a brand new exploit just for you, I'd have to be motivated, have the time and resources to pull that off. Or in fact, I might need an entire team and funding and project management to pull off that attack. So there's a large number of variables that come into play, assessing risk in terms that make sense to that organization and compel or make that argument to management that we have to do something. Wow, I think you hit a chord there, Jason. I just ranted.
Yeah, that's good. You know, two of the types of people we see take the advanced web app pen testing course are either pen testers or web app developers. So for the people who, let's say they're web app developers and they're just implementing these things, how can they start looking at it in a way where they can see the vulnerabilities themselves so that they can understand, hey, there's an issue here?
So one is you have to kind of imagine, okay, how bad is that? What would actually happen if someone did that to me? Let's say you see a banana on the sidewalk, and you can picture in your mind, if I step on the banana, I'm going to fall and it's going to hurt. How bad? It's going to hurt bad enough that I'm going to avoid that banana. So it's picturing in your mind the impact of, okay, we have, let's say, Jenkins in our environment. we have the possibility of an attack against Jenkins because we're running a vulnerable version. What does Jenkins do? What happens if Jenkins died, or if Jenkins, all of its stuff was stolen? What if Jenkins was used to attack other parts of our environment? What does that mean? So telling that story and using our imagination to picture what would happen if something really bad occurred with that. And then once we have that story in our minds, okay, now how do we fix that? And fixing, some people get fixated on patching. It's not just a patch. There may be firewall changes, there might be structural changes, there might be architectural changes, there might be procedural changes, there might be controls you can place around that particular environment to mitigate or reduce the risk of that attack. Does that make sense?
That makes sense.
Awesome.
Right. We don't have any other questions.
Oh my goodness. We're going to finish. Oh, is Carol going to get mad at me if we finish early?
I don't think so. It's 9:45 p.m. in the US.
Yeah. So I only went for 45 minutes. I'm supposed to do a full hour. That means I spoke too quickly.
Do you have any final words for the attendees?
Well, try again. You saw me fail 3 times and succeed the 4th time. Keep on trying. But, you know, people who appreciate web apps and understand how they work often make the best pen testers, even if that's not their frame of mind. I personally have a development background. I took computer science as my 2nd degree. Believe it or not, my 1st degree is in political science, so I argue a lot. But, you know, come out and see what you can do. Don't be afraid of taking advanced courses at SANS, because you will grow to the point where they are useful skills for you.
All right. Well, thank you so much, Adrien, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.
Thanks, everyone.